Hi, sorry I had to be absent on the day of your notes. So instead, I created this notes for you. Hopefully this will be enough. In fact, I think it's actually better. So in front of you right now, you should already have this worksheet. I've already filled out the skeleton of your notes, and all you have to do is fill in the blanks as we go along. So let's take a look. We have just started polyhedrons. Right? So what is a two-dimensional shape called? That two-dimensional shape is called a polygon. Right? As opposed to now we're entering a three-dimensional shape, and lo and behold, it is a polyhedron. Right? In the two-dimensional shape, when we go back, it's always been formed by line segments that are always enclosed. So no matter what the shape looks like, from vertex to vertex, it should be formed by these straight lines. So let's call them segments. This time, in a three-dimensional shape, what encompasses this shape? What are the walls of this shape? Do you remember what they were called? They were called faces. Yes? And essentially, each face is a polygon. It's one of those 2D shapes. So this shape right here could become one face of a three-dimensional polyhedron. Now, we're going to review our polygons real quick and take a look at some of the names. So, for example, a three-sided polygon is called a triangle. Right? And triangles is the most generic, the most general term. Now, a triangle can get more specific. You can have things like maybe an equilateral triangle. You can have maybe a right triangle, or maybe a right isosceles triangle, right? You can also have maybe an obtuse triangle, and so forth and so forth. There are more, yes? Now, what is the most generic four-sided figure called? It is not a square. That is actually the most specific four-sided polygon. It is not a rhombus or a parallelogram. Those are all more specific types. Kites, rhombuses, parallelograms, all of those are definitely much more of the specific type, and there are a ton. Trapezoids. It is the most generic name, of course, is a quadrilateral. Okay? You know what a five-sided polygon is called, right? Here is your pentagon. And then you have regular pentagons, which look more like this. The best that I could do. Yeah. Right? Or you have your irregular polygons, which means I can draw any 5 lines as long as they connect at the end. That is not 5. Maybe I can make that. Hold on. Let's try that again. So 1, 2, 3, 4, 5. There we go. That happens to be a concave irregular pentagon. 6, 7, 8, 9, 10. You can fill out. You know the names of these. They are all either regular or irregular. Is what those are. Now when we go back to polyhedrons, go back to the top for polyhedrons. What is the minimum number of faces a polyhedron can have? The bare minimum number of faces. It is actually 4. You cannot create a 3-dimensional shape with only 3 polygons, 3 faces. So that 4-sided, a polygon with 4 faces, the prefix for 4 is actually tetra. Oops. It's called a tetrahedron. Okay? And there are a 4-sided, when we with all the polyhedrons we worked with in groups, there was one 4-sided polyhedron, and it looked kind of like this. What kind of a shape was that? That shape was called a triangular pyramid. And I don't know why I created, I was supposed to put in your 5-sided polyhedron. I missed. So this is actually supposed to be a 5-sided. So erase that. There is only one way to build a tetrahedron. It is in the form of a triangular pyramid. You can have equilateral triangles, or you can use different kinds of triangles, but it is still going to be a triangular pyramid. What I did miss is the 5-sided. I missed a space for a 5-sided. Let's insert that. Polyhedron. And we know what the prefix for 5 is. It's penta. And now all we have to do is, instead of using the suffix gon, we're going to use hedron. So this would be a pentahedron. Okay. And there are more specific types of pentahedrons, but I didn't leave any space. Let's talk about a hexahedron first. A hexahedron. How many faces would a hexahedron have? Hexa is the prefix for 6. So this would have 6 faces. Now the most famous, there is a very, very famous, the most popular hexahedron. It's a specific type of a hexahedron. It's the kind that you see when you play games or when you gamble, which I'm sure you don't, is a cube, or ice cubes, right? Hexahedrons can also be created into 2 different types of prisms. A square prism is one of them, versus a rectangular prism. Right? And that's both of these are your typical boxes of some sort. Boxes are usually in the form of a rectangular prism. Now, real quick, do you know the difference between a cube and a square prism? Okay. A cube has to be squares all around, right? So this right here is a cube. A square prism just has to have 2 bases here and in the back over here that are squares. But these sides, what we call the lateral sides, can be rectangles, must be rectangles. Well, can be rectangles actually. So that's the difference between a cube and a square prism. You can also build with 6 sides some sort of a pyramid. What can you picture that has 6 sides, 6 faces I should say, but in the form of a pyramid? And that will be, well, pyramid has 1 base, so one of the sides must be taken up by the base. So now we're down to 5 sides left, and those 5 sides need to go on the lateral sides. So that will be a pentagonal. Oops, 1 L. Pyramid. So 1, 2, 3, 4, 5, and then there's a pyramid, so I'm going to drop those edges down this way. So it's a pentagon as a base, and then they're all triangles on the sides. So that would be a pentagonal pyramid. Now, can you guess what an 8-sided polyhedron will be? It is an octahedron. What will the prism look like? Like we said, a prism has 2 bases. So that means 2 of the 8 sides must be taken up by the bases. And the leftover lateral sides is 6 of them. So this would be a hexagonal prism, which we've actually used in, looks like this. So 2 of the bases right here. So 2 bases it has to be 2 out of the 8 bases, and then the leftover, there's 6 left that must form the lateral sides. So it has to be a 6-sided base. So that is a hexagonal prism. We use these in the group work as well. And then, of course, as a pyramid, one of these sides must be taken up as the base. So there's only 7 lateral sides. So this is a heptagonal. I don't even know if that's a word. Heptagonal pyramid. 10-sided is a decahedron. And of course, a 12-sided is a dodecahedron. All right. Okay. Moving on to the back side of your notes. Move on to the back side. Flip your page over, and you should see this part. Let's clarify and write down what the difference is between prisms and pyramids. We've already done these on the classwork. So prisms always have 2 bases, pyramids have 1. Your lateral sides, which means all the parts on the sides, these are the lateral sides. The non-bases are all in the shape of rectangles, as opposed to in a pyramid, all the lateral sides are triangles. Okay. So now how to draw the 2 bases. When you're drawing any kind of a prism, the 2 bases must be congruent, well, for right prisms, I should say. So the ones that are perfectly perpendicular. Right? So they must be congruent, and I can't tilt any of these. They must also be parallel. So the 2 bases must be congruent and parallel. So draw those 2 bases first, and then all you're doing is you're using a straight edge, and you're drawing in, you're connecting the dots basically. Didn't really draw those very well. So something like that. Right? So you just have to make sure that you're connecting the corresponding vertices. Okay? Now up here, if we're talking about a pyramid, the lateral sides are all triangles. We need to draw the base first, some sort of a base that looks like this. And then all you need, instead of connecting these vertices to another base at the top, we're connecting it to one point. So you're just drawing these lines like this. Ta-da! You have what we call a rectangular pyramid. Okay. Going back, since I have 30 seconds left on this video, I do want to show you what an octahedron, well, let's take a look. An octahedron looks like this. Nope. Is this it? 1, 2, 3, 4. Yep, there's 4 faces here, and there's 4 matching faces on the back. No, this is not an octahedron. Just kidding. I think that's a decahedron. Here's a more famous decahedron, actually. 1, 2, 3, 4, 5. 5 on the back. Sometimes these are used as gaming dice. So this is a decahedron. And then the most fun to